Welcome to this video on earthquake geomorphology, a core topic for UPSC geography preparation. We will analyze seismic mechanics, the Earth's interior structure, and earthquake zonation in India. Earthquakes originate at a subterranean point called the focus, or hypocenter. The epicenter is the location on the Earth's surface directly above the focus, where the initial impact is felt. These events are classified by depth, ranging from shallow to deep. The elastic rebound theory explains how tectonic strain energy is stored in rocks and released suddenly during an earthquake. Most seismic activity occurs along plate boundaries, convergent, divergent, and transform. While earthquakes are often natural, human activities like mining, hydraulic fracturing, and large reservoirs can trigger seismic events. Reservoir-induced seismicity, like that observed at the Koyna Dam in Maharashtra, is a key study area. Seismic waves are divided into body waves and surface waves. P waves are the fastest and travel through any material. S waves are slower and only travel through solids. Surface waves are the slowest, but cause the most damage. Variations in seismic wave velocity reveal the Earth's internal layers, marked by distinct discontinuities. These include the Conrad, Moho, Rapetti, Gutenberg, and Lehman discontinuities, each separating different layers of the Earth's interior. Seismic shadow zones confirm the Earth's interior structure. P waves are refracted at the core mantle boundary, creating a shadow zone. The absence of S waves beyond 103 degrees is evidence that the Earth's outer core is liquid. Global seismic activity is concentrated along tectonic plate boundaries. The Circum-Pacific Belt, or Ring of Fire, is the most active zone, accounting for nearly 90% of the world's earthquakes. Tectonic forces cause crustal deformation and faulting. Normal faults, driven by tensional stress, create features like scarps and rift valleys. Strike-slip faults, caused by horizontal shear stress, result in linear valleys and offset streams. Earthquakes often trigger secondary hazards. These include tsunamis caused by submarine displacement, landslides in mountainous terrain, and soil liquefaction, where saturated ground temporarily behaves like a liquid, leading to infrastructure collapse. India is divided into 4 seismic zones based on BIS standards. With 59% of India's landmass vulnerable to seismic activity, understanding these zones is critical for safety and disaster management. The ongoing collision of the Indian and Eurasian plates makes the Himalayas highly prone to major earthquakes. To mitigate risks, the NDMA emphasizes code enforcement, structural retrofitting, and community awareness.